Welcome back to our continuing exploration of Einstein's general relativity and the interpretation of multiverses. A multitude of YouTube videos tackle the complex subject of general relativity and multiverses, and we have listed exemplary references for further exploration. Here, however, we will focus on unpacking the details previously claimed. In the first episode of our series, we introduced the concept that the past, present, and future can coexist simultaneously. We did not thoroughly explain the rationale behind this concept at that time. The episode also implied that such temporal simultaneity leads to superdeterminism without looking into the underlying reasons. Moreover, it presented the many worlds and multiverse interpretations as potential ways to bypass the constraints of superdeterminism, but stopped short of detailing how these interpretations provide a resolution. Relativity, first published by Einstein in 1915, radically changed our understanding of gravity. Unlike Newtonian physics, which envisaged gravity as an invisible force acting between masses, Einstein reinterpreted gravity as the curvature of space-time itself. This theory is mathematically formulated through the Einstein field equations, which describe how matter and energy influence space-time geometry. Different solutions to these equations have produced predictions and discoveries such as the time dilation effect. This phenomenon reveals that there is no single universal clock, which implies that distinct observers may have different measurements of time. Consequently, the concepts of a universal past, present, and future are not absolute but relative, suggesting they can coexist from different perspectives. The idea of now can seem simple, but when you consider physics, it gets complicated. Normally, we don't think about the time light takes to travel when talking about the present moment. However, for a more precise definition, we can't just choose an arbitrary point in time and call it now without some way to measure it accurately. To define now, through a possible experiment, imagine placing two mirrors at equal distances to your right and left. You send out two light photons simultaneously, one to each mirror. The moment the photons reflect back to you at the same time indicates that you're positioned exactly in the middle. At the halfway point of their round trip, the photons are reflecting off the mirrors, defining a now even though their light hasn't yet reached you. However, this gets tricky when relative motion is involved. If someone else passes by in a spaceship and conducts the same experiment, his now won't match yours from your perspective because of how his movement affects the travel time of the light to and from the mirrors. This leads to the principle that the concept of now varies depending on the observer. It's observer-dependent. Your sense of now is different from someone else's, and this difference is known as the relativity of simultaneity. This discrepancy is tiny and unnoticeable at everyday speeds, but becomes significant near the speed of light. If we were moving at such speeds relative to each other, our understanding of now would be very confusing. If you take any two events at big distances, there will always be some observer for whom these events occur simultaneously. Putting these observations together implies the block universe concept, where all times exist simultaneously. In the block universe, there's no coming into being or changing. Everything just is. However, if you struggle to accept that, you might prefer to believe that only the present moment exists, the things now and here. This doesn't lead to a block universe concept, but it's hard to reconcile with Einstein's theory of general relativity. In summary, in the context of general relativity and based on our current understanding, the past appears to exist just as tangibly as the present. However, when the principles of quantum physics enter the conversation, with their inherent uncertainties, they called into question the existence of a predetermined future. This introduces the notion that perhaps there is a distinct now demarcating the boundary between what has occurred and what has yet to unfold. Pursuing this line of thought further may lead one to entertain the prospect of our existence within merely one of countless universes, as posited by interpretations arising from many worlds and string theory. Stay tuned for episode 2, where we will take a closer look at quantum physics and string theory.